Hello, I'm talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolden, and today we're going to do some using net force to find acceleration exemplars. We've been working a lot lately on free body diagrams, and just because there's no free body diagram boxes on this paper that we're going to do doesn't mean that you can't use it. As a matter of fact, as I go through it, I think I will probably use some free body diagrams to figure out what's going on here. Sometimes it makes it a little clearer. So let's get into it. So we're going to use the 5-part problem solving method as we usually do. So as we go, here it says the bighorn sheep has a mass of 70 kilograms, so mass equals 70 kilograms. It begins running forward with a force of 15 newtons. So here's our sheep. Here's our forward force of 15 newtons. So force applied equals 15 newtons. It experienced a 2 Newton force of friction. So in the other direction, because if the sheep is moving forward, the friction acts in the backward direction, in the opposite direction of the movement. So force of friction equals 2 newtons. And to figure out what the F net is here, you need to assign one of these positive and one negative because they're opposing forces, and I try to make the bigger force be positive and the smaller force be negative. So F net is 15 minus 2, which is 13 newtons in the forward direction. Okay. So now we have F net, we have mass, we can find A because we have this lovely formula right here. F net equals the mass times the net acceleration. So 13 newtons equals the mass, which is 70, times the net acceleration. We're going to divide both sides by 70. And when you do that, you get 0.185, so rounding appropriately would be 0.19. And since it's an acceleration, it has to be meters per second squared. And always the net acceleration is in the same direction as the net force, and our net force is in the forward direction. Okay, so that's the first one. Second one, we got a skydiver going on here. Skydiver has a mass of 60 kilograms. It experiences 20 newtons of air resistance, so force of friction is 20 newtons in the upward direction. Let's draw a little free body diagram here. What's going on? Okay, so force of friction is in that direction and it's 20 newtons. After they open their parachute, what's the acceleration of the skydiver? Well, you know from drawing like a quadrillion of these free body diagrams that there's a force due to gravity here, but we don't know what the force due to gravity is, but we do have a way to calculate it because Fg equals mass times the acceleration due to gravity. So that's going to equal mass, which is 60, times the acceleration due to gravity, which we know from doing a bazillion problems is 9.81. When we multiply that together, we get 588.6 newtons down. But that's not the force that we use. We have to use the net force, and that's the force due to gravity plus the force of friction. This one is 588.6 newtons going down. This one is 20 newtons going up. We got to make one of them positive. Let's make the 500 positive, and the other one has to be negative. So this is 588.6 plus a negative 20, not 2. So the net force is 568.6 newtons in the downward direction. So F net equals the mass times the acceleration net, not acceleration due to gravity. So F net is 568.6 equals the mass, which we know is 60, times the acceleration net, which is what we're looking for. So we're going to divide both sides by 60. And when we do that, we get a number 9.476. I'm going to round that off just like that. 9.48 meters per second squared. And what is our direction here? It's going to be down. Okay. So that's the second one. The third example that I wanted to show you today, and I have to readjust my camera a little bit here. Okay, that'll work. So a model rocket has a mass of 2.5 kilograms, starting with a 5-part problem-solving method like we always do. Here's our model rocket over here. Has 2 engines which exert an upward force of 30 newtons each. So we have one force applied, which is 30 newtons, and we have a second one on top of that, which is also 30 newtons. So the total force applied equals 60 newtons. Up. If gravity is acting on the rocket as it takes off, okay, we have force due to gravity here. And they don't give that to us, but we know from the previous problem and from a million problems we did in Chapter 4 that we can find the force due to gravity. So force due to gravity is the mass, which is 2.5, times the acceleration due to gravity, which is 9.81. And when you do the math on that, it ends up being 24.53 newtons downward. So write this in here, 24.53 newtons for the force of gravity. So we got to make one positive and one negative. We'll make the bigger one positive. That means this one has to be negative. So our net force is going to be the applied force plus the force of gravity. And usually our force of gravity is a positive because it's usually the bigger force, but not in this case. And it doesn't really matter if it is or not. So we got a positive 6 plus a negative 24.53. And when you do the math on that, it comes out to 35.47 newtons. And what direction? This is a positive number, and positive was in the upward direction. So force net equals mass times the acceleration net. So force net is 35.47 equals the mass, which is 2.5. Don't forget decimal point. Times the net acceleration. We're going to divide both sides by 2.5, and we end up with 14.188, and we're going to round that off to 14.19, and it's an acceleration, so it's going to be meters per second squared, and in the same direction as our net force, so that's going to be in the upward direction. Okay. So there's 3 problems. There's lots of pieces to these problems, but if you use all the tools that I've given you over the time that we've been studying these, I think you should be okay. So that's it for this time. Have a great day.